Greetings, my name is Hossam, and today I will be representing my group in proposing our smart waste management system. So without further ado, let's start with a brief introduction. With the increase in human population and growth of the global economy, there has been an exponential growth in the waste produced, and hence, in this short presentation, we will be introducing a much better, a much more efficient way of waste management. In a future where processes are being automized to provide humans peace of mind and better efficiencies in those works, similarly, our waste management system will be fully automized. And the question here is, how? The answer is the Internet of Things. Our smart waste management system will revolutionize the way waste management is conducted globally, leading to reduction in costs, pollution, and manual human labor. And if you want to know how, stick with me and you will very soon. But firstly, let's state our problems. Public waste containers overflowing with trash, causing diseases, going unnoticed, and because, as most of you know and realize, that waste management trucks are outside our houses almost daily, this causes a great deal of pollution. So, we are aiming to find customized paths for waste management trucks to reduce trips, leading to less pollution and reduction in staff. And also, automizing the waste management system for homes, offices, industries, public and private properties. Now imagine the amount of pollution brought about by each one of those trucks that I just talked about earlier. Why isn't our waste management system automated yet? In a world where remote control and management are dominant, why are our waste management systems still outdated? Anyways, let's dive deeper into the methodology of our proposal. Infrared, gas, humidity, and temperature sensors were used to measure the volume, toxicity, humidity, and temperature levels of the waste in our smart bins. This is done by attaching the sensors into the interior of our waste management bins. Sensors are then connected to Wi-Fi equipped ESP8266 microchip, which when triggered by a sensor, it conveys the data to a designated server via nearby Wi-Fi. This server could be owned by a waste management company or a waste management governmental body. There you have it, a smart bin that reports data to a server, and that's the first step. One of the biggest upsides to our proposal is that it comes with a solar panel. This solar panel, battery, and a solar charge controller are used to power the components, ensuring portability and clean energy for waste containers. And that is a big, big upside. Moving on, our approach to automate waste collection processes was by producing real-time data on waste collection at various locations. What this basically means is that we wanted to gain insight into the state and condition of every single bin in every neighborhood, in every city, in every state, even at country level. This will allow the concerned bodies to plan less frequent and more efficient trips, thus reducing pollution, and at the same time requiring much less manpower. Because when you have all this data at your fingertips, things will definitely get easier. We want to allow waste management bodies to better plan their waste collection strategies through effectively mobilizing their trucks, while at the same time reducing the number of trucks and workforces needed. At a very low cost and through the brilliance of the Internet of Things based applications, our product embodies a forward leap in the field of waste management and technology by providing extreme benefits to any user. And like I mentioned earlier, our bins can literally be installed everywhere. If they are outside, they can run on renewable energy power supply through the solar panels. If they are indoors, they could definitely be modified to fit a power supply. Over the course of this project, a few devices, controllers, and applications were utilized, namely a DHT11 temperature and humidity sensor, an MQ135 gas sensor for CO2 and ammonia detection, an infrared sensor to know if the bin is full, a Node MCU ESP8266 microcontroller with built-in Wi-Fi capabilities, and last but not least, our Blink app for monitoring the status of our bin. Here is how it goes. All our three sensors, namely our gas, our infrared, and our temperature and humidity sensors, are connected to the Node MCU microcontroller. If the trash bin is full, the IR sensor is blocked, and hence it results in a message or a warning sent to the user. If the gas sensor detects high levels of ammonia or carbon dioxide concentrations inside our waste collection bin, it will also send out a notification to the user. Similarly, for the temperature and humidity sensor, as high temperature would mean that materials and matter is rotting quickly inside our trash bins, and in a smart bin, you do not want that to happen. It will also send out an early warning. Before demonstrating the operation of our system, here's a quick glimpse at the source code used. Now, here we have our Node MCU ESP8266 microchip with Wi-Fi capabilities. Down there, we have our temperature and humidity sensor EHT11, and next to it, we have our gas sensor MQ135. Lastly, our IR sensor. Now all these sensors are connected through Wi-Fi and onto our application Blink. This application allows us to display real-time data gathered by our sensors and onto the application. So let's test it, shall we? We're going to start with the IR sensor. We're going to point the IR sensor towards that little elephant right there, if you can see it. And we want to see what happens when the IR rays are blocked by that elephant. You basically get a notification. Trash is full. That is because trash has risen to the level of the IR sensor. Now we have our humidity and temperature sensor. Let's test it out, shall we? And for that, we're going to need the help of our little blow dryer right here. We're basically having a temperature of 30 degrees as a preset value. Once exceeded, we will get a notification. So let's see what happens. 28.4, 28.6, 28.8, and boom, 30. You get a notification. The temperature is too high. So you know that something is going on with that trash bin. Then, moving on, we have our gas sensor, but unfortunately we won't be able to test it due to the unavailability of toxic gases in our surroundings. So we just suffice to say that it takes about 24 hours for it to work properly. Nonetheless, we can still see our real-time data. So as soon as this data goes over an index of 10, it will send another notification or warning as well. So that will be all for this demonstration. Later on, when we actually implement this into our bin, we are going to use the same setup and try to fix it as nicely as possible into the ergonomics of our bin and connect it over Wi-Fi. That way, we will be able to monitor our bins. Despite putting forward our best efforts, yet there were some limitations and barriers that hurdled us from achieving the full potential of this project. Those were, firstly, delays in mail services. Due to the current situation, many important components arrived very late. We were unable to have practical meetings. We did have online meetings, but as we all know, practical meetings face-to-face are very much different. The availability of Wi-Fi networks will be a barrier for the implementation of our project. And this thing crossed our minds actually, because we were thinking about implementing our project in a smart city. And in a smart city, you can't call it smart if you don't really have Wi-Fi coverage everywhere. Am I right? But we're still prepared because the same way our bins are equipped with Wi-Fi capabilities, they could also be equipped with 4G and 5G capabilities. Parameters that were used in this demonstration were assumed for tests only. They're nothing too real. The gas sensors need a warm-up of 24 hours before they can perform stably, as I mentioned earlier, which we didn't really account for, and that's our fault. And lastly, our solar panel has not arrived in time for us to shoot this video. So maybe in the future, when this comes to life, we'll be able to see it fully fledged. Thank you.